Hello. So this is my half of the presentation. This gentleman over here is going to have another half of the presentation. We were billed as two people that have differing opinions. Let's see if that works. All right, so the agenda for today, I hate agendas, so you can see. I'm going to do some intro stuff. Why? How? Did it work? What worked? What didn't work? And then we're going to talk about hallucinations, and then Steve's going to talk about a bunch of very complicated stuff. Okay, I am Mark Randel. I'm a senior software engineer with JKI. I've been engineering for over 35 years. Yeah, thank you. And started with LabVIEW 2.0 way back in the 90s. I've been in pretty much every industry that there is, including spent 6+ years at SpaceX at their engine test facility in McGregor. Steve?
Is this thing on? Can you hear me?
Yes.
That's awesome. All right. I'm Steve Ball. I am also a LabVIEW developer for almost 20 years.
Youngster.
Been around a little bit. So I'm excited to be here today and talk to you about AI and LLMs. I am a big contributor, the author of Jake AI's agentic backend. And also, I read ML papers for fun. It's become one of my interests in the past few years.
Nerd alert. Okay. So before we get going, let's do a poll. Who here uses AI or LLMs? You know, it's like ChatGPT and everything. All right. Now, keep your hands up. Keep your hands up. Now, of all those people, keep your hand up if you're successfully using it with LabVIEW. That's what I thought. There's one guy, and he's lying. Okay. So what do we do now with LLMs and stuff? So we can do some really quick text programming. Those are awesome. Great for research. I used it to plan my trip over here. Language translation, which is handy if you're not in the UK. Then also, Steve likes to make music. I like to write fiction, and we love the cool pictures we can make, don't we?
I didn't think you'd put that in the presentation.
I know. There's more to come, dude.
Oh,
all right. So why do we want to test LLMs with LabVIEW? First of all, AI is the hotness, and it's everywhere. Everybody's touting their AI. For text-based programming, I've been forced to use Python on a handful of occasions, which I am not familiar with. I'm a LabVIEW guy through and through. It's fantastic. I don't have to think, look up, or anything, so it saves me a lot of time and effort. Also, it's just a very quick solution. So naturally, we want to see, can we do this with LabVIEW? Should we do this with LabVIEw? And then the last thing, can it even happen with LabVIEW? So I went with a very simple test, and I wanted to set up a test structure that would actually be useful to me in a project I was working on. I wanted to create a very simple build VI. And I didn't want it to be too complex. All I was trying to do is get the build version from a project file. So this is the exact prompt that I structured and I placed into multiple AIs just to see how well they worked. Now here's what I expected. On the first one, I expected to see it breaks down into 4 steps. Step 1 is I want to open up that project as a reference. There are many ways to do that. This is the way I chose to. It's not open for discussion. The next method, or the next step in this process, is I need the actual build specifications from that project. And you'll notice it's that bottom property node, I'm getting the owned items. That comes into play later. Then also, next step, I want to find which of these build specs are actually building an executable. Because you can have a whole bunch of different types of things in your build specs, or in the build folder. And then this last one. This is the reason I chose this, because the actual version values are not properties. They are tags. and there is no property to read. You actually execute a read tag function, and you have to know what those tags are. Even more, if the value is 0, the tag doesn't exist. So it's sort of it's a trick question that I wanted to put to the AIs. And then after I got done with it, they all pointed to this other method, which is already a pre-canned VI, we'll see, which was very disappointing. So here are my test subjects. I hit the big 5. These are the big ones that most people use. And then I also threw in there JKI's own JKI, your creation, partly.
In part.
In part. Yeah, I still blame you. All right. And then also National Instruments, Nigel, brand spanking new. As a matter of fact, I had to rewrite my presentation when they came out with that over the summer. Yay. All right. So let's get right to it. Who passed? Nobody. Copilot just failed straight out. Gemini, ChatGPT, and Grok all came close. But if you notice that partial on step 2, they all specified the children array property, not the owned items property. And I even went back and asked, why? Why did you choose this one over that one? And they answered exactly oppositely correct. And they insisted that I was wrong. Yeah. And then the success, I put the little, footnote number 2, because they all chose to use the Git build specification version VI, and not a single one attempted to show me how to do it discreetly. Now, JKI, I am sad to say, just didn't do it. And Nigel, well, we'll get to what he replied back with. So, what worked? What did work is they all returned back very clear structured steps. They also had occasionally some correct references. And by using all 7 of these, I was able to cobble together how I could actually do what I was trying to do. And then JKI, to its benefit, is agentic. So even though it didn't give me the right answers there, it was able to, it's the only one that was able to look into what I currently had open and give me immediate feedback correctly. But other than that, that's what worked. What didn't work? Yeah, at the bottom, that's what I got from Nigel. And I bet I'm not the only one, because I asked Steve. Steve?
Well, Mark was kind enough to screen share with me, and we replicated the issue.
Okay, I have validation. And I tried this for the last month prior, because I did not want to throw NI under the bus on anything, but I could not get this thing to work. So what did not work is they all came back suggesting I get the children array instead of the owned items array. And what else didn't work is not a single one of them provides me a picture or an actual snippet of VI code that I can use. They all come back with some sort of one or other variation of a code block. Some even titled in Mathematica. Okay. Nigel just simply did not work the best I could try. And they all made stuff up, and which we call hallucinations. And that is the big failure across the board with all the LLMs. They would just make up stuff left and right. It's like appref.openproject does not exist. None of those exist. But when it gives it to you very confidently and says, this is gonna work. And so I spent half of my time chasing around trying to find those things that don't exist. Because it's working from a phantom API, that it's just because if it doesn't have all the information, it just fills in the blanks on where it thinks it should be. But whatever it did reply back with, it was always confident, which was so frustrating. So why do they fail so bad? Well, it's the execution gap. When you are working in Python with an LLM or any of the other text-based languages, they will actually have a way to simulate that under the hood. They can actually test that through their own API. And LabVIEW does not exist within those. So they're just doing the best they can from the reference material available on the internet and through what documentation is available through NI's website. So, and then also, they can only produce pseudocode. They cannot give you an actual snippet that you can drag and drop. The same problems are across the industry, actually, as it turns out. And we're going to see some headlines here in a little bit.
Foreshadowing.
Foreshadowing, yeah. And then lastly, the biggest failure is the fact that LabVIEW files, they are binary. It's a graphical binary file. So LLMs don't have access to it like they do text files. So when do I choose to use an AI? And I was asked to put this together by Steve, to say, do I know what I'm doing? Do it. Can I figure it out? Do it. Is there good help available? Then just do it. Is there an example? Then just do it. If none of those suffice, then I'll resort to an AI.
As a last resort.
You'd be surprised how many times I don't know anything. So in summary, they're promising but very faulty. And the good side is they are good for explanations, brainstorming, translations, and making really good pictures, and complimenting my prompts. I got more compliments doing this process. It's like, oh, that's a brilliant idea. Thank you. And bad is they are not accurate at all. So if you're using one, always verify before just tossing in the code. I invite you to read the wise words from ChatGPT. The shape of destiny. It's brilliant. It just sends shivers down my spine.
Thank you, Mark. That's very inspiring.
Almost done. And then, thank you. Thank you so much. And at this point, Steve, would you care to take over? I'm going to ramble on briefly while we do a little quick computer swap, because Steve's side of this whole thing was to prove me wrong. Show me how good the AIs of this time are. And let's see what you came up with.
Let's see if this works.
Is it working?
Does it work?
Almost. Okay.
Okay.
Presentation mode.
I need to
There you go.
do, what is this, F11 maybe? Yeah. Okay, so cool. One more second. So, Mark, I thought that we would be more in disagreement when we started off here. But after we talked a few times about this, we were a little closer together than we thought. Let me just maximize this. Yeah, so let's go on. So Mark already had you do a show of hands of who's used LLMs. The Stack Overflow survey for 2025 also shows that these tools have pretty much saturated the marketplace for text-based languages too, and people are using them. It's like 80% of developers have used them, and the satisfaction that people have with the tooling from 2024 to 2025 dropped by 10% as more people are being exposed to LLMs and agentic coding tools. People are finding to find the cracks and the weaknesses and to have gripes with the technology. And let's talk a little bit about why that is. So LLMs are really good at some things, and they're really bad at others. Mark just showed you that example where we tried one very specific prompt in LabVIEW, and it just falls all apart, no matter what AI you use. When Mark initially showed me his presentation and this prompt, I was like, dude, I could do that.
He should do better. He's an expert.
And I thought I could do better, but it turns out that this is, I couldn't do any better than this with chain of thought prompting, proper context engineering. The models just lack the appropriate amount of training data for the domain of LabVIEW programming. And that seems like even when you use the best tools available and techniques, they still kind of fall on their face. So thanks for that, Mark.
Oh, anytime.
Yeah. So there's kind of a deeper principle. Here we have these large language models that want to do everything for everyone. They want to be very horizontal and know all the information in the world. We ran out of human information, and we still can't make these models any bigger or have more exposure. But real intelligence is not having all the knowledge in the world and knowing what it is. It's really about being able to work with what you have in a smart way. So this quote kind of illustrates that. We see the headlines. Basically, here the FDA was developing an internal tool to help with drug classification. And as they kind of rolled it out from MVP to testing, people are finding this over and over again, basically, is the hallucination problem where their own internal tool is making up fake studies. And this is stopping the project in its tracks. Here's another example, medical AI looking at images of MRI and X-ray. They found that the AI system they made was able to predict the race of the patient as the patient had self-identified on their medical data. It was able to do this not only like automatically, but from like pixelated, deformed image files that were not optimal. And there's no way that the researchers could figure out how it was doing that. So it creates this incredible risk where we have some sort of bias built into the AI system that we have no idea of how it's operating or what kinds of ways that would affect its predictions or outcomes. Again, in the legal realm, we've seen, this was from May, there were something like $38,000 in sanctions against lawyers who are using ChatGPT in the courtroom for their filings. The judges are catching it, and they're over-relying on these tools to do legal work. I think in these domains, medical, legal, there's a rate of about 5 to 7% hallucinations, which is way higher than the benchmarks or the general hallucination rate, which has fallen to like below 1%.
I guess it's important when you take a document to court to actually remove your own prompt out of the copied document.
Absolutely. As a large language model, I would, right? You have your clear tells, so it's not, it's pretty obvious.
Yeah.
So here's another report. So the total estimated cost of AI hallucinations, $67 billion last year. I think this number is only going to grow in the future. Same report, 47% of enterprise users, people using AI to assist in making decisions where AI probably has no business making a recommendation. So this is a big systemic risk that we're exposing all across our economies and business sectors where we're using AI, I'd say, where we should be using it more cautiously. Okay, I got to keep moving. We have just a lot of slides to get through.
Didn't we talk about the black box already?
I think we talked about black boxes
we've
already
already-
today, right?
Black boxes aren't good, right?
So let's start off with why are LLMs bad at math? They got better. They have tools and agents and things, but fundamentally, these are statistical systems. We've all tried to ask ChatGPT, or we've seen it, how many R's are in strawberry? This is the same exact principle. They look at all the data and in this compressed embedding space and use statistical loss functions to optimize, hey, this is the answer most of the time to my math problem. But if I run the multiplication through the LLM, I'm going to get a distribution of different answers where one of them is only really correct, and I only ever really want that one answer. So for engineering, it's super important that we have these deterministic behaviors. We need to be able to replicate the issue, to debug it, and to be able to reason about how our software is working. So we're kind of changing kind of our viewpoint from, and I just went forward too many times. Can I go back?
Yeah, bottom.
On the bottom. All right, cool. Clicker technology is beyond me at the moment. So we're transitioning from using LLMs like ChatGPT, right, and talking about integrating that into our actual work, into our actual software. Okay, so as part of that transition, we're going to talk about these explainable AI. Right now, people are trying to figure out how the LLMs work. There's a couple techniques. This chart, Mark, you were asking me about this earlier.
Yes.
This is the GitHub stars on the different software repos that explain how the LLMs, or they attempt to explain how the LLMs get to their answers. It's like reverse engineering an equation with a billion parameters. It's really hard to do. And paper after paper has come out and shown that it's not effective. And what the result of that is the state of the art of explaining a big black box LLM looks like is you can train your SHAP or your Lime model, these are the different names of them, and they'll come up with different answers, even when you use the same model and train it on the same data. So it's very, I'd say, young and not adequate for really understanding how the model's getting to its answer. Also, when we're talking about explainable AI, there's this huge crisis where a meta-study found that only a very small number of papers, 1%, they're actually doing the studies with people to see if they actually understand what's quote-unquote explainable, makes sense to us, the people. So that kind of culminates in the CEO of Anthropic putting the statement out there, I think, is a challenge to steer the whole industry and to raise awareness that the lack of understanding of these giant modern LLMs is just unprecedented.
I'm glad it's not just me then.
Okay. Well, I've been working in the AI space and following and reading papers, and I think at this point, there's kind of a way forward, especially for domains that are narrower, if we're not trying to do everything in the world like an LLM. We don't need a big black box that has knowledge of all of Wikipedia for an engineering application. So LLMs are out. I'd like to introduce architecture called CBMs, context bottleneck models. They've been around for about 5 years. For cross-region compatibility, I have a picture of the North American and European robin. Instead of having a black box, we have this neural architecture that's trained on human understandable concepts. This is just one of the emerging technologies. There's a lot of other things in the pipeline. But when we think about it this way, the neural component gives us the concepts. So instead of just getting the answer, we get the classification. It's a robin, and we're this sure about it. But we can also see, oh, it was red, it's small, it has perching type feet. With the the confidence metrics in there as well. So it's very helpful. So you could see just combining the pieces and doing systems integration, which is something that everyone in this room is probably very experienced with. We start taking a context bottleneck model, our understandable concepts. We write the if-then logic. If this happens and this happens, do that. We can all do that pretty easily, combine it with our engineering domain knowledge. And then we've got some AI system that is explainable, it makes sense, and we can debug it. It gives us all the things that we want. So I did a weekend project just to try to prove this out. I made a small CVM. I wrote some rules about physics, and I asked a lot of questions to a small LLM about conservation of energy and things like that. When my rules output the answer, I fed it back into the LLM, kind of like when Mark's working with the LLM about LabVIEW and saying, no, that's not right. Do this instead. So that's how the system basically works. That improved the answers of Llama 3.1 on a standard 100 physics question data set by about 10%. So it's kind of similar to using like a RAG system, except I'm working in constraints and concepts and adding some text. I thought that was a neat proof of concept. So putting it all together, we have the big companies that are creating these giant horizontal LLMs that are not optimized for engineering, for medicine, for law, for finance. There's just these huge sectors of the economy where it's not appropriate at all to be relying on LLMs for as much as they are today. A couple of weeks ago, MIT had a report come out that said all of these companies that are trying to make AI projects, the projects are failing. There's a big gap in between creating an MVP and actually putting out a product that has the kind of reliability and trust that we would expect for our own code. So I think the big players in the industry are focusing on the wrong things with the big LLMs, and we need to start working on these vertical domains, building trust, reproducibility, the same engineering principles that we have in the LabVIEW community. We're going to say no to black boxes. We're going to build our systems deterministic, traceable. We can verify how they work and maintain them as we continue to work on them. So it's not about waiting for another company in another industry, in Silicon Valley, these big players, to build an AI that we can use as the LabVIEW community. It's about recognizing what exists, what's out there, and how do we assemble the pieces in a way that makes sense for our own use cases. Thank you.